So I'm going to compress 3 years of study into 15 minutes. So we're going to do the entire Colorado coordinated campaign overview in 3 minutes, or 15 minutes, but we're actually going to just talk about part of it, which is what we tried to do in order to reconcile some parts of the data that we were getting from a number of different sources in this study. So this is a classic top-down, bottom-up reconciliation project. So this is one of these cases where we have aircraft, we have people on the ground, we're collecting activity data. Generally we're just harassing the operators nonstop to get the job done. Okay. And so this is in the DJ Basin, so it's just east of I-25, right near where we are, and it was funded by money from CDPHE and the Colorado Oil and Gas Commission to do this work. So the aircraft was a carbon mapper. We had some folks on the ground, but I'm going to talk about the top and the bottom here. So basically aircraft and activity data. Okay, so what we wanted to do was to look at how often the basin scale survey, this is one of the broad area surveys, sees maintenance events and kind of what impact that would have. And so what we did was come up with a model. This looks very much like what Lyra just put up with. But if you see the gray parts behind the kind of stack of emissions, that gray portion is kind of what the aircraft sees. So sometimes it sees maintenance, sometimes it sees large fugitives, sometimes it sees other stuff that's going on the basin, or on the sites. And what we're trying to do is figure out which parts of the gray, the part that the aircraft saw, went into one of those categories. And so we found that there are three uncertainties that weren't really well characterized in that scale-up process. So if you go out, you get a bunch of plumes, you add them up somehow, and you estimate emissions at the basin, kind of what are you missing? What assumptions are you making, and how will those affect your scale-up? And this is getting really important, right? Because we just had IMEO get up a few minutes ago and say that they were going to tie things down at a basin level. And this is how they're going to do it. Okay, so we need to know what the accuracy is behind this. So the first thing I'm going to talk about, though, is the thing nobody ever talks about, which was how do you actually know where anything is? Okay? Now, it turns out that this is a huge, huge job. And I'm going to show you some pictures. So this is an arbitrary, and by arbitrary, I mean I'm too lazy to find an interesting place. So I just took some chunk of the DJ Basin. This one's about 3 by 4 kilometers. I've got some pipeline data on there. I've got some site data on there. So you get kind of an idea of what this piece of the DJ Basin looks like. Okay? We're going to zoom in on a few of those pieces. So this one is 2 facilities. Different companies, they're about 120 meters apart, and every arrow around the outside is a flow line that went out of that block. Okay, so the well is someplace else. Okay, here's another one. The midstream facility is in the middle there, okay? Everything that's marked in white are wells going into one well pad. Everything marked in yellow are well pads that are in wells that are in a different well pad. Okay, so a typical scaling strategy or understanding strategy is to find the wellhead data, which is easy to get, and then say that's where the operator is. The operator ain't there, okay? The operator's someplace else. Could be hundreds of meters away to even multiple kilometers away. And then this final one, this large block over here, all of this stuff is a CAFO, so a confined animal feeding operation, a feedlot, okay? And all the yellow circles are well pads around that CAFO, okay? Now, I didn't go hunting for this, okay? This is what the DJ Basin looks like. It's looks like this all over the place. So everything you see after this point was based upon being able to assemble all of that GIS data. So when we talk about flying over facilities, we have an overflight count. It's because we actually knew where the stuff was the carbon mapper flew over. And it seems like an obvious thing. It turns out it's actually quite hard to do. And if you're going to try to attribute things to operators or do diagnostics on a top-down plume detection, just figuring out where it belongs is quite interesting. So we came up with about 12,000 chunks of disturbed ground in the flight area, which is about 4,000 kilometers square. Okay, and about, you can see the count there of kind of what's operating versus what's shut in. But even on just the operating side, you're still talking about 6,000 or 7,000 operating facilities. The DJ Basin isn't the biggest basin around, right? So they get bigger. Okay, so let's talk a little bit about what we actually found. So we went out and did a lot of maintenance events. We had 4 of the largest operators, covered about 80 or 90, well, 88, 92, something like that, % of all production. Gave us all their maintenance activity for the times we flew, plus a bunch of times around there. So we had a pretty good feel of all the maintenance events happened in a 6-week period. And out of those few thousand events, about 8.5% of them could possibly maybe been overflown when they were active, okay? Now, they're not active all the time, so there's little pulses of gas coming out in those maintenance events. But, it's not a trivial number, but it's not, a huge number either, okay? Now, when you look at the timing of those maintenance events, they're in the middle of the day, okay? And when you look at when planes can fly, when they have enough return radiation signal from the ground, it's in the middle of the day. So these are very well correlated. And just keep in mind that the start time on the maintenance activity is before the maintenance event happens, whereas the start time of the airplane flight, the orange part, is only a few minutes before the airplane flies overhead. Okay, so these are actually more aligned than they appear here, because the blue would be shifted to the right. Okay, so these are right on top of each other, so there's a good chance that they would overlap. And then in times, day of the week, you see a big split between weekdays and weekends. Why Thursdays are a hot day for maintenance in the DJ Basin, anybody can guess. It's probably some statistical fluke, but what you do see is a big change, kind of about 2 to 1 in the amount of events that are happening in weekdays and weekends. And why is that? Right? It's because, well, people want to be out in the day, and they want to be out in the work week, and they want to be doing something else the rest of the time, right? So that's very human caused. So the first check we did was to say, is there any correlation? So now that we know where the facilities are, we can now count when we were over the top of facilities. So we have an overflight count, that's on the x-axis here, okay? And thousands of facilities overflown. And then on the y-axis is basically how many plumes we got. Now, we don't have a lot of flights on the weekend, only a couple. So it's not really like definitive, because you don't have enough data, but you do see there's a difference. So there's a clue there that says, yes, we must be getting some maintenance events, because we do see a change in plumes. So at the top down, just a glance, you can see that there is a difference, okay? So we went about doing a plume matching exercise. So we had a double-blind experiment up front where people just gave us their maintenance activities, which is a good exercise in finding out how well people keep track of their stuff, as you'll find out in a moment, okay? And then we did a stage 2 where we unblinded it. We told everybody where the plumes were, and then they had another chance to respond, okay? And then the remaining plumes, you'd say, well, those are caused by something else. So up front, you get about 10%. Okay, of the plumes match up, and they match up pretty well. So if it said unloading from a tank, you go there, you look, it's a tank, it's unloading, it's a big plume, right? So it matches up fairly well. On the second stage, you find out that there's a bunch of things that people forgot to tell you about, okay? Some of them were designed, like they weren't going to tell us about pre-production, and they didn't, and it turns out pre-production got hit a lot, okay? And other times it was, well, we merged 3 companies together over the last 2 years, and, that part of the company didn't answer. So some of those were just kind of missing data. Some of them were maybe a little bit more speculative, so we weighted those. So we didn't give everybody 100% credit, okay? But still, you end up with a number that's probably north of 20% of all the plumes were maintenance events, okay? I mean, it could be as high as almost half. Okay. Now, the interesting part about that is those are in the day, okay? If you went after a different type of top-down sampling thing, you're going to see those same emissions because they mostly work during the day, right? They're also temporary. I mean, they're short periods. And it's very hard for a top-down method to get anything like an accurate answer because they're very transient in size. So they have a very changeable size. So that will have an impact on what you see. And this is production only, by the way. We're going to get to midstream, which is even more interesting. Okay, but this gives you an idea of what we found. Okay. Now, midstream, we had a different problem. So we have a bunch of blobs and a few plumes sitting over the top of midstream facilities. So it turns out there wasn't great wind all the time. When we were out in 2021, the transport wasn't great. Okay, so a lot of times the combination of just vertical lift from the exhaust, combustion slip and stuff, plus being coupled with kind of poor wind conditions in general, meant that it was an indistinct origins of the plumes on midstream, okay? In addition, you have big compressor slip emissions, tens, even 100 kilogram per hour type of slip. So what we did is we went in a different analysis process. We said, do we see plumes multiple times? How many times was this thing overflowing? What fraction of the time did we have a plume? Okay, so on the bottom axis here is an estimated mean emissions from the facility. So that's what we can get by doing some inventory guesses. Is it right? Probably not, but it's not all that far off, right? It's a good ballpark. Arthur Santos is sitting out there someplace, and he did that for me, so you can complain to him. Okay, and then on the other axis is what fraction of the time did the aircraft actually see something at that facility, okay? So if you have a facility that's got maybe 100 kilograms per hour of combustion slip emissions, you really like to be seeing it all the time, or if it's something you can't sense, never, okay? So it'd be like in one bucket or the other. But the reality is what you do is you see it. There is some correlation. You see them more, but you don't see them all the time. In fact, you see them less than half of the time. Okay, now I'm not saying anything about accuracy here, about whether they see them correctly, just whether it's seen at all. So the aircraft flies overhead, and then due to some other factor, somewhat arbitrary wind conditions or whatever, you may or may not see the plumes. Okay, and this can be the case where you see zero, you never see it for whatever reason, and other times when you see it maybe 30 or 40% of the time. Now the result of that means that for midstream, you end up with this kind of interesting problem where the maintenance emissions are pretty rare to start with. So we have 0 examples of catching maintenance. We have some upset conditions. We did catch, but no maintenance. We have some large fugitives, okay? Sometimes clearly you can pick those out in the plumes, okay? And then we have a bunch of normal stuff that sort of arbitrarily gets picked up sometimes and not other times, right? So you don't really know what the midstream is. And this leads to kind of an interesting problem. It's the second bullet on this page, which is in the bottom-up inventory, where we've spent a lot of time working on detailed models for the DJ Basin. The bottom-up inventory says it's about 2/3 midstream, and it's 1/3 production. And by the way, the companies kind of agree with that report. So it's not something we invented, right? That's what they're reporting. But when the aircraft flies, you get the reverse. It's about 1/3 in midstream and 2/3 in production. It's just reversed. So, that has actionable problems for any type of use you're going to make of that data, okay? So what we're seeing is a summary that there's a couple of issues with scaling up from plumes to basins that really haven't been characterized. And those are related to either the temporal variability of emissions, particularly large maintenance emissions. And then the second thing is there's certain classes of emitters that are kind of intermittently and unpredictably sensed. So they sort of show up sometimes, and they don't show up other times, and that unpredictability can skew things on a sector-to-sector basis, or maybe on a total basis as well. Now I want to close this by saying all of the numbers I gave you are on counts, only counts. So we're only talking about the number of instances where something was seen or reported, not whether it was seen correctly or reported correctly. That's kind of a separate question, right? So we don't know whether the maintenance the calculated maintenance emission sizes are correct. So I'm not trying to make a statement about accuracy of the total, more about the fact that we have this sort of risk factor of trying to understand the scaling across a basin. So thank you very much.